Sorry, guys, just give me 1 second here. Jen Moyer, can you hear me on the call?
We can hear you.
I want to see if Jen Moyer is on the call here.
We can hear you.
Great, just give me 1 sec here. Hang on, guys. Hang on, guys. I'm getting there.
Nothing to see, you just have to listen.
That's a lot of.
Jen Moyer, are you on the call?
Yep, I am.
I think you use my Zoom and you're still the host, I think, no?
It says I'm logged in as me.
You're right, Salter.
Let me go check my laptop. Hang on.
No.
I know that.
I'll get one.
This is it. Thank you.
Hey, Dr. Joe.
Look at Phil, they're patting my back.
You will now join the choir in Tierra del Fuego. It's the southern city in the world, the gateway to Antarctica and the largest civilization.
Look where this camera is.
The Bulgarian Navy battleship sailed.
Aaron. Oh, now I'm unmuted. Yeah, you too, man. All right, I'll hang up.
Can you hear me?
That's better.
You can hear me, but it's echoing, eh?
Sounds like you got birds chirping.
Hang on 1 second. Oh, there's transfers to your microphone. Press microphone. Can you hear me now, Joe?
I do.
Okay, so let's go here. Okay, so I think we're going to get rolling here. And welcome, ladies and gentlemen. Thank you for the patience with the technical difficulties. Holy geez. Anyways, I'm excited. I'm excited to have Dr. Joe Baldino with us tonight. Now, Dr. Joe is a graduate of the National University of Health Sciences, earning his doctorate in chiropractic to add onto his triple majors in biology. Now, Dr. Joe is on our medical advisory board and has 1,000 hours in postgraduate studies in clinical rehabilitative neurology, vestibular concussion, and TBI rehabilitation, just to name a few. He, aside from being a great guy, he has 15 years of clinical experience with hundreds of hours under the guidance of Dr. Carrick from the Carrick Institute. Dr. Baldino is the founder of Integrative Neurology and Athletic Performance in Illinois, where he focuses his practice on these studies. Dr. Joe's passion for helping others is undeniable. His ability to give hope to those suffering is life-changing. And Dr. Baldino has been able to combine his degrees, knowledge, and compassion to a great system of hope, health, and healing. The methodology he employs to help people is unparalleled in knowledge, passion, and excitement. And I have come to know Dr. Joe Baldino as a friend, as a colleague, and he is an incredible guy. He cares a lot for the field. He is an amazing speaker, and I'm just delighted to have him on the call tonight. So without further delay, take it away, Dr. Joe. It's all yours.
Hey, bud. It's nice seeing you again, by the way. Thank you very much. That was more than I expected to hear about myself. Most of the time, I have no idea half of the things that I do. But yeah, without a doubt, I'm definitely very much invested in anything I learn and how I can use it to benefit more humankind. That's what I love about this platform and using all the technology that Vox has actually helped, especially enhance a lot of the treatments that I do here at the clinic too. So thank you. Thank you for asking me to be on, and hopefully I could be of service to you all tonight too. I'm not very good at reading things.
Do you need to screen share it all, Joe?
It's like there's a lot of loud beeping. Feedback is painful.
This is absolutely crazy.
Too many crickets in the house. Yeah, that's what it sounds like there. Harry, your microphone looks muted from my end.
You hear me now? But I'm getting an unbelievable echo for some reason. I'm gonna try logging out, Joe, and logging back in again. Give me 1 second.
You want me to?
You can try it, but I got two Terry St. Amans, which means somebody has used my account and not given me back the host again. So I wonder if that has something to do with it. Try logging out and log back in again.
Okay.
You guys hear me? Can anybody hear me on a call? Jen Moyer, are you on the call? Hello. Yeah. I don't know what's going on here. Yeah, I'm just gonna see. I'm gonna try and log back in again here. Hang on 1 second. But I got two hosts under my name. So it's either you or Paul. You're the only two people that have my Zoom account. I'm gonna try and log again. Let me just see here. Yeah, try logging out again. Everybody's gonna be on the. No, I don't. I shouldn't have to. Let's see if I can. Yeah, because I'm logged out. So somebody still has logged into my account and hasn't given me the back. So whoever logged in, it's probably Paul Austin. It's logged in as me, so he may have to take over the call because he's logged in as my name probably, but he has his own account. Okay, so can you take over host? Okay, see participant. Can you hear me on the call? No, there's two on mine. Yeah. No, I know. I'm back on the call again, so I'm just trying to find. What are you logged in as? What name? Yeah, are you on your phone? Okay. No worries. I'll figure it out. No, it's all right. I see you as iPad 4. I was looking for Paul on here too. Did he? Well, I'm just trying to see if Joe even got back on the call here. So I don't even know whether Joe got back on the call here. Yep. I don't see him on here. Are you on the call right now, Jen? Can you make an announcement? I'm going to, yeah, that's fine. Mm-hmm. It's really weird why it's. Second. Where's he under? A key. Yeah, I'm trying to find him in my list here. AC. So hang on 1 second. I'm gonna see if Angela's on here somewhere. Yeah, I see. You're under iPad 4. There's your iPad 4. So they can't even get the host. Yeah. So let me just see if I can get you here, Jen. Let's just 1 second here. Technology is great when it works. Can you unmute yourself? You can't unmute yourself, eh? I know, but I'm trying to get that done. That's the problem. Okay, here we go. There you are, Jen. Okay. Okay, you're now the host, Jen. Won't let you unmute him either, as the host even. It's weird, right? Let me see if I can make Joe the host. You should be able to do it if you're the host, right? So what I'd like to do is just start another link and post it. So I'll just just sent a new link. He just posted right back in the team page again. See if we can log back on again. As the host, you can't unmute him, eh? I'm trying to even find him in my list. I can't even find him. Oh, there he is. There he is. And you can't. I'm going to try to reclaim back the host. I'm going to try to unmute him. Okay, now he's unmuted. But he probably still can't hear me.
Wait, I hear you now. I'm unmuted.
Yeah, you're unmuted. Can you hear me without an echo?
I was just gonna start writing cue cards. That was Stan's idea.
Writer's cramp. Oh my God. I don't know what we even did, but a little stressful. Oh well. Anyways, welcome, Dr. Joe. We're so glad you have patience. We all have patience. So anyways, you're rocking now. Did you want to share your screen, or you just want to talk, or what's the deal?
Oh, well, during all that, I said everything I needed to say. I figured I was done.
Oh, did you record it?
Yeah, I just said it. I was like, okay, and have a good night, everybody. Thank you for having me.
Thanks for coming. Sorry, Terry's an idiot. But if I make you the host, you can probably share your screen.
And then, oh, okay.
So I just made you the host. So see if you can go down to the screen share at the bottom of your.
I see it. Yep.
And allow you to screen share.
Let me see. Well, all right. Yeah. So well, what I was thinking is just going through some of the slides, more of the pertinent slides that I went over in Niagara regarding the EEG study.
Yeah.
And that touched on so many different things. I mean, it was a lot of information to try to fit into an hour and a half, but I could elaborate a little bit more on particular areas, like why, essentially, like what we want to cover tonight is why you'd want to, like, the cumulative effects of wearing or being exposed to the technology over time.
Yeah,
right?
I think that's important, Dr. Joe, just simply because we've got a lot of new people on this call. We've had a lot of growth in the team, and I think we've all learned so much with the help of the studies that you guys have done, the research that you've done, the actual patients that you've treated with this technology on. And
Right.
I think really what we wanted to get across is the importance of wearing this and the cumulative value, but and why that is, why it's important and in relation to 30 Day, because generally what I found is most of the time when a new person comes on board, or they're first introduced to the tech, they think, wow, they wear it 1 or 2 days, and like, this they may or may not see results.
Yeah.
And so I think that's really important for our field, especially for the new people, to sort of understand, how we're initiating the response in the brain stem to wake up the body's own innate, and how that gets better with time. So maybe we could touch on that a little bit with the chat too, and then maybe I'll just monitor the chat and see if I'll mark questions as we go, and we'll hold off the questions till the end. Does that make sense?
Yeah, that would be good. So, well, if there's new folks on the call too, there was a study that was done that compiled the results of EEG scans of 60 participants, 60 different people, and the summary, essentially the lecture was about the summary of that study, and with the application of the socks versus no socks. And it showed all these far-reaching different regions of actually the cortical regions of the brain, which each little region of the brain is like a different neighborhood. So every neighborhood has a little bit of a different function that kind of makes the whole city work. So what I tried to do was go through a lot of the pertinent areas, or the ones that were most relevant to everyday life, even especially the life that I see clinical, patients that come in with certain demise, certain dysfunctions, different diseases, and with the application of the socks or the patch, seeing how it just amplified, or it made any treatment I was accustomed to doing that much more relevant and actually longer lasting. And it did have an cumulative effect over time for a great many people. So I'll kind of touch on all that stuff. I won't go through the whole study, you know, with Thatcher talking about the summary of the whole thing. Is that in the back office stuff that people could access it? Or I don't know if it is.
I think your slide presentation is that we touched on in Niagara, Joe, that I've seen, but
Gotcha. Well, what I could do, I'll see if I could do it this way. I'll play a little bit of it and kind of fast forward through some of the clip. It's a movie clip.
yeah.
And just kind of show you, like, look at what happens with the socks off. And then as we keep going, the socks on, and then how different parts of the brain start to wake up with activity. And then I'll kind of dissect that out.
Perfect.
Is that good?
That sounds awesome.
Okay, let me figure out how to get to it now. Just share.
Did you click on the screen share down at the bottom?
I did.
And then it should call up like 3 sort of windows on. There you go. You got
Is
it.
It's doing it now?
You got it. You're on fire.
All right, so let me see if I can get this video just to play, because let me see something here.
Hey, we've made it through 100% of our problems so far tonight.
Good.
We're batting 100. Let's go.
That's right. That's awesome. So this is the study. This is actually the title of the white paper that's being published, and it's going to be exposed to peer-reviewed literature, and a lot of people are going to dissect this. The actual study, this is a summary of it. Dr. Thatcher, who actually holds 2 Lifetime Achievement Awards in the production of EEG studies, which is it's like the gold standard of how you map somebody's brain to figure out what circuits are working and how they're working and things like that. So in this, he mapped 60 participants, and at rest with no socks on, this was the average activity of most of those people's brains. So in order to stay at rest, you still need some brain activity to actually inhibit all that you can do. So it's like there's an off switch that's still active that's actually inhibiting all the functions, right? So these are folks just sitting there idly, pretty dormant. When they applied the socks, the most profound thing was the parameters of the study in the statistical way were 0.01. It gave it a p-value, which in stats is it's almost 100% reliable, 100% confidence in all the parameters of the test that what we're seeing is actually true. In most studies that in neurology, in biomechanics, in a lot of different biochemical studies, you'll get a p-value that's almost around 0.005. So you have a 95% confidence rate in those studies, which is also pretty much what all science is like. Well, that's okay. It's still 95%. There's better studies that are 0.001. So in this test, the way they designed it, the confidence level was almost 99%. So what we're seeing is actual. We don't have to change data or scrub it or anything like that. It's pretty pure. So as Thatcher goes through this, let me see if it plays. And let me know if you can hear Thatcher's voice too.
This is a video of the difference between current density between the EEG in the brain and the sources of the EEG, between the condition of resting and as a baseline versus placing socks on the same subjects and then recording the EEG after the socks have been on, and then comparing the difference between the EEG with the socks off versus the EEG with the socks on. In this case, it's an eyes open condition. It represents a cross-validation of the eyes closed condition. So there's independent measures. And this is a paired t-test from 60 subjects. Degrees of freedom were 58. I set the t here at 3.5, and the probability of setting for the t-test at that level and those degrees of freedom is p less than 0.001. The red here are the voxels in the brain. The values of the t-values are shown in the bottom on the box on the right. And you can see the differences between socks on and socks off. At 1 cycle per second, I'm going to go to 2 cycles per second.
So at 2 cycles per second, he's talking about when they're measuring different brain waves with the application of the socks. Okay, so if you just notice that one shift in the amount of real estate that lit up with activity in the brain, and this is just looking at the left hemisphere, right? The brain is looking off to, I don't know which side of your screen it's facing. Hopefully it's like mine. But for me, it's facing to the left, my left. So the left front of the brain lit up with activity. Now, every centimeter or so, every half a centimeter, has a different functional correlation. Some areas of this part of the brain relate to the ability to speak. Some areas relate to the ability to move. Some are the ability to make a good decision, right? And if Paul was here, we would talk a whole lot about that. But I'm not going to do that in front of right now yet. We'll see. So this part, he talks and he cycles through different brain waves, and I'm going to go over those in a little bit. I just kind of want to give you the overview of the study, and then we'll dissect it a little bit more. That way you have a little bit of knowledge on the inner working part of the areas of the brain that are actually activated with the application of the tech. Cool?
Cool.
All right.
Second, you can see that it's a bilateral significant difference.
So we saw both
including the
hemispheres.
midline regions of the projections, basically of the feet. Too.
So in the brain, and we're going to go over the map of the brain, if somebody was to touch your feet so you can feel it, the middle area of your brain, in the middle of both hemispheres, is the area that lights up with activity. That's the area that feels your feet, essentially. Okay.
The medial banks of the motor cortex, but there's also posterior temporal and particularly on the left side, but it's on both sides. And you can see the difference of the significant differences here. I can look at just the left brain half.
Right. So now he's taking the left half of the brain and turning it so you see the inside half of the left side of the brain. Okay. So it's like we cut it in half and we're looking at the inside like a cantaloupe kind of thing. And what he's showing is these red areas are lit up with activity. The interesting part is a lot of this is the limbic system. A lot of these areas fire into the area of our emotions and the limbic circuits, which are usually the most primitive stuff to humankind, and everything on top of that is kind of gravy. Okay.
So see this medial surface as a significant difference, as well as the right, as well as the occipital cortex. So we're going to march through the t-tests at frequencies from now 1 to 2. I'll go up to 8 hertz.
It just keeps going up. Yep.
There was a more scattering of significant differences. All of the subjects showed differences at these higher frequencies as well as the lower frequencies.
Yeah.
But the effect size was strongest between 1 and about 10 hertz. Again, this is at 3 hertz. There's 4 hertz. Again, the left hemisphere is more significant than the right. 5 hertz, 6 hertz, and this midline region here, which is that's a somatosensory projection of the feet to the cortex, 7 hertz, and then 8 hertz is no longer significant.
Right.
So this is a quick condition. Have socks on versus socks off. The difference in the current density being produced by the brain between those two conditions. That was the condition of the same subject, 60 subjects, RT test, is a baseline versus putting the socks on. Thank you for watching.
So,
Wow.
So it's pretty cool stuff. If you just see the gravity of just applying the tech to the skin of the soles of the feet or the bottom of the feet, literally starts to cause the brain to shift in its resting activity, especially in the brain waves of 0 to about 8 hertz, which is usually the ones that we see most active in healing, in regeneration, in rest, digestion, kind of creating balance in the body. You know, so a lot of the times we want the body in that kind of brainwave state if we want to do any kind of healing. Now, brainwaves There's a variety of them. And they go, some of them have been measured into the hundreds too. Those are the ones you need to be hyper alert and vigilant and focused versus the ones you get just before you kind of wake up, like that twilighty sort of daze or you're in a fog. Those are the ones your body's at the most sort of relaxed in a way, okay? So that was the Thatcher talking about those findings of the study, and then we started dissecting it a little bit more. Let me see if I can bring this up. So we're gonna skip through a bunch of the slides. Can you see the whole slide, or is it the split screen thing?
I can see the slide with the split screen with the yellow brain and then the
Okay.
3 images.
It was a video.
Side view and
Good. So this one, just giving thanks to Jay. Again, he developed this stuff, and it's quite remarkable what I've seen clinically. You know, so a lot of the stuff, like in Niagara, it's like I know I have a short amount of time to talk, and I have a lot of information to share.
hey, Joe, let me tell you, you keep going. People want to stay, they can stay, and if they don't, they can.
Okay.
So this is good stuff, man.
Okay, well, so that's what this is referring to, just that the expectation is just don't worry about what I'm trying to teach. You're not all going to learn it in an hour. You know what I mean? But I just want to see if we can paint a good picture so that you have a deeper understanding of how really important this tech is to humankind. All right?
Perfect.
So a lot of the stuff, we'll go through a little bit of anatomy. We'll go through some functions. I'll go through basically how sensory information gets up into the brain. And then we'll go through what different brain waves are. There's something called Broadman areas. That is kind of the different neighborhoods in the brain are all listed by numbers. They began from like numbers 1 through 52, and over the years, a lot have been added. So now there's about 88 different neighborhoods that have very particular functions. And then again, that'll summarize the whole EEG finding stuff. And then what I'm going to do too is I added a case study of mine, one of my very most profound case studies I treat in my clinic a lot of traumatic brain injury. And it's variety. Some is mild, some is pretty severe, from injuries where brain is removed to injuries where it's a concussion and the person looks fairly normal, but they're losing all sorts of functions. So this one case I'm going to share with you tonight is a hockey player, and horrible concussion for him, and the application of the tech on his feet and what it did, and I use a lot of objective testing in here. So we do a lot with eye movement and balance and equilibrium, and we measure everything so that objectively we all are looking at the same findings, versus it's not just me at the bedside saying, oh, you look better, but they don't feel better, and vice versa. So now we have ways of objectifying it so that it keeps me in check as a therapist, but also to make sure that the patient realizes their brain is shifting as a consequence. Plus, it also gives us a good baseline once they come into the office, because a lot of times I'm probably the 20th to 30th doctor that these kind of cases have seen, because they go to places, and not to say they just get kind of plateaued, you know, and it's just the nature of treating the human condition is the brain gets used to certain things repetitively, and it just kind of stays there. So we've been fortunate enough where we constantly have a lot of shifts and changes, and the application of Vox has definitely enhanced a lot of the treatments that I've been used to seeing over the past about 12 to 15 years. So we're gonna go through a bunch of that stuff. This slide was really just made for Paul. If you all know Paul, it was so Paul wouldn't just blurt out and talk during the lecture, because we had a lot to get over, and I just asked him if he could just stop talking. And sometimes he doesn't have the inhibition like most of we do. And I don't have a mute button. I could just do that. So anyways, we'll just go into some of the anatomy of the brain. So essentially, this is half of the brain, all right? And we're looking at it from a side view. So the yellow is the front part of the brain. The purple is the back side of the brain. The yellow is affiliated more with high human functions, even movement and motor and things like that. The red part of the brain is affiliated with sensory, like if I touch your shoulder or your hand, there's an area in that part of the brain that says I'm touching your shoulder or your hand or something like that. So blue is usually associated with memory, your ability to remember your first kiss or the inability to forget it, that kind of thing. It just kind of sits in there. And then the purple is the area you see with. Essentially, the light goes from the yellow part or under the yellow part all the way back to the purple part, and that's where you actually form an image that creates your world, essentially. So we'll talk a little bit about all these things as we go on, okay? Let's see, here we go. So this part is if we cut the brain down the middle to the midline. This is the spinal cord area. Hey, can you see the cursor on the screen too?
Yep, absolutely.
Okay, good. So I don't know how to change the color, but hopefully I'll just try to highlight stuff.
No, we can see it fine.
Okay, so this is the brain. This is the spinal cord, like the most midline. Here's the area of the medulla. This is like your respiratory and your digestion and your heart rate and rhythm. This is like your vital centers all right here. This is what keeps you alive, even if you were unconscious, okay? This is stuff you don't have to think about, right? Like remembering to breathe. Well, we got to remind Paul a lot, like, Paul, take in breath. Like, you need that stuff. He's like, oh, yeah. Breathe. Because he just talks run-ons, just on and on. It's like, how do you even get air up there anymore, man? So the area behind this is the area we use for like coordination. So this is your ability to like coordinate, like finger to nose or shake a hand or you know, food to your mouth. Or it also coordinates your thoughts, you know, so you don't just have random sporadic delusional type of thoughts. You know, you can have orchestrated thoughts that have sort of a pattern to them too. That exists in this area of the cerebellum, or it helps with it. If you go higher up in the brain, this green section, this is what they would call your limbic system or your emotional system, okay? And if you notice, like the emotional system of humankind, it's so deep in the brain, right? And then on top of it are the layers of who you are as a human, how you sense your body, and what you see, like the purple, the red, and the yellow, right? So all of the other things that's just kind of the icing on the cake, it all sits on top of the emotional system of humankind. So in my practice, everybody's condition, especially if they're chronic, it has an emotional component to it. And it's because this is like your instinctual areas. And I'll go into a little example later on, you know, like when you first see somebody walking toward you, how do you know to reach out to shake your hand or run the other way in a very basic way? So we'll go over some of that stuff too. Now, just to give you perspective, this is a dissection I was involved with where that's an actual human brain. And where my thumb is kind of where the spinal cord would be going down. And then here's the back of the brain where I'm circling. Here's the front of the brain. And if you to judge how big the brain is, it's about the length of my hand, okay? And I don't have in particularly gargantuan hands, you know, so this is a pretty small piece of tissue up there, mostly made of lipids, fats, and some protein, really. So this is the middle part of the brain. This is that whole cingulate area, that limbic area in here. Here's something called the corpus callosum, which is like the bridge of communication that goes back and forth between left and right side. It's a big highway of information. And this is another perspective. Here's the brainstem. This is the pons. This is the area where you regulate all facial stuff. So like touch to your face or your ability to chew. This is also where your breathing, your respiratory centers are, your ability to take a breath, breathe out. Just beneath it is the area that regulates all the organs in your body as well. And it's a very small area. I would say no longer than a centimeter and probably half that in width. And that's what regulates all the organs. Like your whole torso is controlled by this little tiny area. Just to give you perspective, that's like my index finger right there. So I mean, this is a very tiny piece of tissue. Like,
were you dissecting this on your picnic table?
yeah, this was Thanksgiving, and I just got bored of eating turkey.
That's not a turkey's brainstem. Is it that? You sure
You're
that's-
right. No. Paul was feeling kind of generous, and he donated his to me, so it was really nice. But
Sorry, I couldn't help myself.
yeah. So those areas, just to give you an example, like this is a solid piece of tissue. Like it's soft when it's living. When you preserve it, it's a little hard, but it's all solid. Every little millimeter in there, it makes something. It does something. It means something. So in a cartoon anatomy book, they just kind of depict it in these ways. Like you have motor, you have blue ones are like the sensory system, the red ones are the motor system, just to show you how interdigitated everything really is. Nothing is really separate, you know, so every sensory has a motor component to it and vice versa, okay? And it all goes through the brainstem. And when you go into the spinal cord, which is even smaller, like my pinky, it's like all this information from the brain goes out through this little tiny bridge of communication and gets to govern your whole body, right? Most of it you don't know how to do or move or do. Everything is reflexive, and it's reflexive based on a lot of different systems in the brain too. But this one, the spinal cord, so this is, again, I'm just holding it kind of like this, so the cord would be coming out towards you. And this is where sensory system comes in, and this is where motor comes out. Motor's in the front, sensory's in the back. Essentially, that's how we're put together. In particular, this little tiny dot where the probe is poking is the system that takes pain up through from your whole body. All the pain signals go up through this little tiny head of a pin type of area in the spinal cord. So it's quite remarkable. You have one on each side that goes up. Like if I pinch your arm here, it travels up through the cord to tell your area of your brain that represents this arm, like where is the pinch coming from. So it's not like I pinch your arm and you feel it in your knee, you know. Well, some people do, Mr. Austin. So the sensory systems that we really depend on, the more important ones are the constant sensory system ones. Those are the ones where, like, we're beings of pressure and gravity. So since you've been born, essentially gravity has been on you 100% of your life, right? In the womb, it's kind of this anti-gravity sort of sensation. They say that you're floating, you know. But once you hit gravity, gravity is on you 100% of your life. Every muscle, skin, bone, joint, hair, everything senses gravity all the time. So that's considered a constant stim into the brain. Because it's constant, your brain is constantly being fed that constant information so that it has to constantly make adaptations so that you can navigate the world, okay, without having to think of it mentally, right? Like walking and chew gum. And we know who can't do that. Don't make me say his name.
There was a note here that said he's gone for counseling.
Yeah, he should, and I applaud him. Finally, you know, hopefully they give him crayons so that we could understand what he's trying to say. But it'll be nice once he's renewed again.
He'll be doing the ink blot test right now.
Yeah, that's a dangerous test for Mr. Paul, that's for sure. It may cause nightmares. But so we want constant stim in this brain, and we just want it to be accurate. When it's inaccurate, that's what causes the brain itself to change its way, and then you develop compensatory sort of ways about you, whether it's an organ function or a motor function. So people develop a limp if all of a sudden their foot's not feeling right, or people develop poor kidney filtration if certain areas of their brain are saying, oh, we have too much water, get the rest out, or we're not conserving enough. It changes the function to the organs. So again, the organs are just doing what they're told. And when I say organs, I mean anything from your heart to muscle tissue to your gut to your bladder to kidneys and things like that. So these are all the different ways of getting sensory systems in. And in my practice, you know, in school they taught us, you know, light and sound and touch and taste and smell, you know, we're all the five senses. And we learned that since we were in, you know, grade school. But what I've learned is the sense of body position, body awareness, and really the area of the brain that takes in all this constant information about where you are in space, that's probably the most important system, because once that starts to fail, like that's when you start losing drastic function. Because most people can have a fairly decent and normal life without really any problems with, if they're blind, if they're deaf, if they can't taste, if they can't smell, you know, like you can navigate the world still pretty well. But the moment you lose the ability to judge kind of the accuracy of where your body ends and then the world begins, that's where I start seeing so many different people develop all these different conditions, but really they're rooted in one system that's failing. So we'll talk a little bit about that too later on, how Fox lights that system up in the brain. And this is fairly accurate in the different areas, like here's the visual cortex, the auditory cortex, the gustatory, where you taste from, these sort of things. If you were to recall Dr. Thatcher's, like where the red part of the brain was lighting up, a lot of these areas were encompassed in that spreading redness. So a lot of these areas are just enhanced with the application of Vox. This is a basic one on how to get sensory stuff into the brain, right? So you have receptors, that whatever it may be, a light receptor, a touch receptor, a movement receptor, smell, taste, whatever it is. You even have electrical receptors, pressure receptors, so many different things. They fire up through an area called the cerebellum, and then that fires over to a different part of the brain, it crosses over, and then eventually you get to the cortex for actual processing. So most of the sensory stuff you are capable of receiving is unconscious. It stays unconscious until it gets up to your brain to actually be perceived. If you just think of the examples of, like, everybody's probably touched something really hot and kind of flinched away. That is usually because the hot, that sense took so long to get to the brain, before you actually perceived it was hot, you were already moving based on a reflexive reflex that we have. So the moment your skin told a part of your unconscious brain that you're touching something that could damage you if you stay there too long, right? It was already contracting muscles beyond conscious control. Does that make sense so far?
No.
So that's kind of a lot of the stim that the HTP stuff stimulates through that brainstem and the spinal cord as well. So these are just some studies I put in there just to show you the mapping of the cutaneous receptors of the sole of the foot. Like all these receptors, there's 159 of them that are very distinct, and depending on how they're stimulated and in what sequence, that's what gives us this response that lights up the brainstem. And how Jay always talks about kind of hacking the brain, where you kind of figure out the decoding portion of the computer programming behind the electrical stuff that fires the brain. Okay, so these are just some studies that exist out there. You can look that up. You just type in receptors of the soles of the feet, and you could find there's this study, I think, is from '02, and they always have more and more and reproducible studies. This one's from a couple years ago, but then the firing patterns and firing characteristics of those same receptors made a difference in what parts of the brain that were lit up with activity. Okay, so we know all this information, and what's neat is HTP kind of pulls it all together to actually wake up different parts of the brainstem. Same sort of diagram, just a different study. And then this is just, I think we had a short break, but so this was referring to reading, like how you can read something over and over and over again, and then you don't need the book anymore to remember what you read, right? So that they call that concept in neurology plasticity, or plastic, like moldable, like hot plastic would be. All right. So this is a slide I found on a neuropsychology journal website. I thought I cited it somewhere, but this was just a nice way they depicted it, like how the brain actually changes, where you have, neurogenesis, which is, brain growth based on the stimulation that brain is in. All right. And then the brain starts to formulate new synapses, literally new connections with different brain cells that weren't talking at one point, and now they're starting to communicate again. Now, what happens with repetition, the synapses strengthen, and then they keep growing, and then eventually they become permanent. But it's like a very real use it or lose it phenomenon in our brain and body too, but it's a reflection of brain first. Is, you know, like I took years of Spanish as a requirement in high school, never spoke a word of Spanish after high school, and now I still can't speak a word of Spanish. You know, it's just, I learned it so well and I did great, but then I never used it again. So those synapses I used at one point just to pass the class, they just fizzled away. And now I do not have it, you know? So that's kind of just one example on how neuroplasticity can work through your benefit, but also your detriment too. You know, it's the same thing with, if you want to hear something negative, we get patients in here with PTSD, you know, something that they suffer from. But what happens is every time that PTSD is fired or triggered, they get an emotional response. And that emotional response is attached to something else. And then every time they see that, it fires this circuit and it becomes more and more strong. So the key is interrupting the bad circuits while you enhance kind of the good circuits, okay? Just in general. But this is, again, oh, here's the citation. If you wanted to read any of this stuff, How Neuroplasticity Changes the Brain by Rousseau. They have it in this one journal article, and again, most of it was based on neuropsychology, but and addictions and things like that. But they just made it really a nice, simple way to understand how the brain changes itself, but also how you kind of have some control into what environment you put your brain in and what changes you get to cause in that brain, if you're aware of it, at least. So National Institute, behavioral medicine, same thing. Like neuroplasticity can result from trauma, right? Like, how do you know not to touch fire, right? That was an immediate, you know, how many times have you put your hand in fire and been surprised it's hot or it's gonna burn? You know, if you ever look at Paul's hands, oh, they're fried. Like he takes a while to learn, but he catches on quick. So anyways, stress can do it. Social interactions can do it as well. You know, just being part of a group, hanging out with friends every day, playing cards every day with a group of people, that actually helps preserve so many brain cells. So especially people that I see in the upper decades of life where they retire, and you know, we're all taught, oh, you retire, it's smooth sailing, it's just you get to relax, no stress. It's worse, because what happens is all these connections you depended on, your daily routine, your drive to work, the people you talk to every day, your brain was like soaking that up. But then the moment that stim is gone, the brain starts to almost literally unravel, where now you don't say hi to Jan every morning or bring somebody coffee or take the same route. Then all of a sudden those cells, the brain doesn't need to keep them. So what happens? It starts to prune them away. Okay, so engaging yourself after some life-changing event is super important. We see some of the most demise in folks who have a radical shift in life where they go from a social to non-social. So it's very important. Our brains are really wired for communication and community. So that's another thing. Meditation can help. Every emotion that you are capable of experiencing, whether you deem it good or bad, doesn't matter to the brain. The brain thinks in absolute values. It doesn't have a negative or a positive pole to it. That's more of your mind, okay? So when I talk about emotions, at least in the clinical setting, it's more of your survival instincts. Like when you walk into a room, kind of that gut feeling you get. That's an emotion, right? Your mind is what tags that emotion with some quality to tell you, do you walk in that room or do you leave that room, kind of thing. Any kind of learning you can do will increase brain growth. Paying attention, like just being able to stay on task, is a huge brain event. Actually, all the fuel you give your brain, and some of the bad fuel too, a lot of that stuff has a lot to do with how well your brain can grow. Physical exercise, and it could be anything. It could be just going for a walk. It could be just laying in bed and moving your arms and legs around in a fashion like you're painting a picture. That is brain exercise, okay? You don't have to break a sweat to have exercise up there. You really just need to use this body so that the brain feels like, oh, well, this is necessary, all right? And of course, like new experiences, everything novel is so important to your brain. Like in my house, I drive everyone nuts, even whether they live with me or they come over, because anytime I get to put the dishes away, I put them in a different place all the time, and that's a nightmare for a lot of people. But for me, it's to keep my brain novel, so that when I don't have to think about, oh, where's the dish? The moment I don't have to think about where my glasses are, right, then I change everything around, because that means now my brain isn't getting this new experience. As trivial as it seems, it makes a good impact in keeping every brain cell viable and pertinent, okay? So don't say no to much. A lot of times, if you just take a different route to the store, or instead of going in the store and turning left, turn right, you know, just do little things differently, and your brain will just be more attentive to it. So again, I'm not going to just read through the slides, but this neuroplasticity is what makes your brain adaptable. And as a species, we need adaptable brains, because things are going to change as you get older, and you move one way or you don't, or you're faced with certain things. You can't be so regimented, otherwise your brain just won't thrive, it won't grow. And then when you get injured, your recovery is going to be far worse too. So your neuroplasticity, the concept of neuroplasticity, is really why we're able to recover from a lot of illnesses or strokes or any kind of injuries, really. But you also have to know, on the dark side, it means you know, your brain's always learning. So it, like I said earlier, it doesn't know the difference between good and bad. Your brain doesn't know that. Your brain is just a piece of fat up there regulating this body. Essentially, think of your body as just a method to carry your brain around. It really is what it looks like. And so your mind is kind of this construct out of the brain that is who you are, but that's more in the psychological realm, okay? So a lot of the stuff that we do in the clinic is we try to break people of all these, you know, unhelpful sort of circuits in the brain, right? So there's Donald Hebb back in the 1950s coined this term, like neurons that fire together, wire together. It still holds true today. I mean, it's absolutely true. If a neuron fires, it fires to the next one. If they fire simultaneously, they literally feed back and forth on each other to promote their own survival. It's an interesting phenomenon. So your brain, even though in pictures it looks like this static ball doing nothing, if you look at it under real time, it is non-stop, like in the milliseconds, always going. Like there's something happening all the time. YouTube has tons of clips on this. If you just type in neuroplasticity or neurons firing together in YouTube, you'll see tons of different clips in petri dishes where neurons are just budding out and start to talk to each other, and then they form all these relationships together. It's fascinating stuff. So pretty much all brain cells need is that reason to fire, right? They need a purpose, and then fuel. So fuel comes in the form of like oxygen and sugar, basically. But not like the sugar like M&Ms and carbs and stuff. It's really like meats and vegetables and fat. Our body is designed to take that stuff in, convert it to the sugar that the brain needs to fuel itself. Okay, we run into a lot of problems when you just have excessive carbs and sugar. That's what causes the breakdown of a lot of other things, which then leads to other problems. But we need fuel and stim, so that also if your lifestyle or you get an injury or a disease that omits part of that brain, like there was a year I broke a leg, and that leg I couldn't use it, right? Otherwise it either hurt or I just couldn't walk. So the leg muscles atrophy because I wasn't using it. So the body is like, well, we're not going to dedicate calories to keep a useless piece of tissue alive. So what happened is the area of my brain that represents my leg, that atrophies as well. So now the leg is kind of a directly proportional representation of how much my brain was shrinking, essentially, at least in the area of the leg part. So that when I had to get the leg moving again, have it be useful, right? It was a painful rehabilitation process, but the more you did it, the legs start to plump up, which then meant the brain areas started to become more viable again. So that's the idea of plasticity. It shrunk when I didn't need it. When I started using it again, it kind of came back online. As long as everything was healthy, essentially. So if you lose, you know, if you lose brain cells, you lose the potential that they were attached to as well. You know, and we're losing brain cells all the time. But we just hope the slower you lose them, the better you are, the better your life is, the better your aging gets, all that stuff too. So in the brain, it's very, very real. Use it or lose it. So I kind of put this one together just to give you an idea. All right. So brain cell really needs the ability to adapt. And the beauty is brains do it without you having to think about it. They're inherently able to adapt. So you just need fuel and you need the activation, right? So this is just a representation to say like, okay, you got fuel, that's good. The system is healthy. Then you have activation. Now, for this example, we could just say, like we're forming a memory, like you're studying for a test, or you're trying to learn about neuroplasticity, right? So then you're reading and reading and reading all these concepts, and then that fires neuron A. Neuron A is connected to B, and then C and D, and then finally get the function of a memory, of a new concept. So the cool part is the activation directly stimulates A, right? But what you don't see is B then gets stimulated by A, right? The problem is B doesn't get direct activation from the outside world. So B's survival depends on neurons A stimulation. So neuron B will then make a connection back to A, right? So it's kind of like they kiss each other. A kisses B, B kisses A. And it just creates this nice circuit so that B's survival is kind of guaranteed, that A will keep feeding it. So then it creates this relationship. So then same thing goes down the chain where B goes to C. C then fires back to B, but then C also recognizes, well, B depends on A. C will also lend a hand and make sure A is maintained because its survival depends on both of these, right? And then what happens with D, same thing down the line. So then all of a sudden now you're forming this very dense network of cells that all are self-sufficient, so they depend on each other. So eventually you don't need the activation anymore for this circuit to maintain. Does that make sense? That's a broad view of how neuroplasticity works. So then you don't need the book anymore to remember that fact or whatever it may be, a motor signal and things like that. So this is how the brain actually changes. So I'll talk a little bit about the brain waves, right? We won't go into all of them, but I'll show you that most of them are measured by these EEGs or QEEGs in cycles per second, right? This is kind of the readings that we get with this not mass, but these tips and base. They all go to different regions around the brain, and they literally can measure the wavelengths and the different frequencies of firing in the brain itself in different in literally the different areas of the brain geographically, essentially. So it comes out with, you know, readings like this. Looks like EEGs or EKGs, really. And then we're taught on how to decipher them. And this is what those studies showed in a lot of it. But every time I think of the brain or the EEGs or brain waves, I just have this image of an orchestra where there's all these different sections, like there's brass and percussion and woodwinds and string instruments and things of that nature. There's all these different specialized regions, and the brain waves are like the music that they produce. And sometimes you need the percussion louder, and sometimes you need the winds louder. You know, there's all these different correlations to that. So I just think of it like a symphony with the way the brain is. So when somebody approaches me as a patient, I'm always thinking of, okay, how they come in gives me a great deal into like what level of is their brain waves at, essentially. You can tell that over time. But I'll just go through like 5 of them real quick. There's the delta waves. These are the real slow ones. These are the ones associated essentially with pain relief. This is access to your unconscious mind, which is kind of where you want all your help to come from. This is where healing and regeneration occur. And most babies in the womb are found to be heightened in delta wave activity. So it's all just rest and digest, and they're at one with the universe. There's no stress, right? That's cortisol decreases with it. Serotonin, melatonin increase, which is like sleep rest cycles, but also your feel good chemistry. Plus serotonin helps all gut functions and things like that too. They also recognize that delta waves, people who can access this have more ability to be empathetic. Now, empathy is a really interesting concept with the brain, because it's almost like you can feel what somebody else is feeling, which is usually not how we're taught. Like if I touch you, I can't tell you what it feels like to be touched by me. You know, it just doesn't work that way. But people with empathy, they usually have heightened delta waves, which is really cool. Then the next one up that's a little bit faster, these are the theta waves. So it's like delta, theta. These are the gateways to like learning. So you need delta, you need to be kind of more relaxed to be able to learn and have memory, but also intuition lives in this area too. So that gut feeling you get, if you're real good gut feeling, then usually you have good theta wave productivity, you know. Whereas you take somebody like Mr. Austin and you go driving with that guy, and his intuition, you just, hey Paul, which way should we go? He's like, oh, we should go left, and you know you need to go right. So you don't listen to his, because he's never in theta. He's always in the higher ones, right? Because he's like a hamster on a wheel. It just goes and goes and goes. So these are the areas of inner peace. Let's see, that's theta, yeah, subconscious mind. And then this is kind of that twilight state, like as you're going to sleep and everything's really calm with the world and everything's peaceful and you can go to sleep nicely without being forced to sleep or anything like that, then usually that's theta waves that takes care of all that stuff.
So Dr. Joe, if somebody is got low theta waves, whatever, they'll definitely have trouble sleeping?
Many times, yeah. Because usually what we see is if they're not in theta, they're usually in the higher brain waves, which is more the ones you need for alert and arousal. Even though their mind says, I need to go to sleep, I have to wake up in a certain amount of time. But people who can't sleep or have insomnia, they usually have heightened beta and gamma wave functions, but also they could have some things in other regions of the brain working too, not just the brainwave part, but also the clinical part as well. Yeah. Then you get into alpha waves. This is kind of what keeps you on the present moment, and this is what I've seen really help people, because this bridges like all the stuff you think about what you have to get done tomorrow versus, you know, your worries about the past or how much you have to do next week or by next week, like a deadline. Alpha kind of helps bring you back from that so that you can get to like the delta and the theta waves as well, so that you actually can calm down and be present in the moment. So one of the things we do here, a high amount, is we teach people how to be present. Like whether you call it meditation or prayer, or I don't care what you call it, but it's essentially just you're focused on my thumb and follow my thumb. And if they can follow my thumb, I know they can't be thinking about anything else, even for those 2 or 3 seconds. So we do those exercises so often that then they can do it at home and they can increase alpha waves. Now, alpha waves is also important. Again, it could be in a heightened state, like a soldier, like has to be focused. You have to be present. You have to be on, right? But it can also give you that area of your brain where you have these free thoughts. And I always think of my dog, like if I'm out for a walk, right, where, and that's what this picture down here always reminds me of, is like if I'm out for a walk, a nice quiet walk, and I have this beautiful earth to go look at, and all of a sudden I'm not thinking about anything that I'm doing presently. Almost like my drive home. I barely remember every drive home I've ever had. I'm not thinking about driving. You know what I mean? I'm just kind of on autopilot, and all of a sudden I'm home. You know, but it's like, how often do you remember every building you saw, or every car, or license plate number, or things like that? It just shows we're not present. We're not in alpha waves, especially leaving work, where work is all day long. You're constantly in beta and gamma. You need something to bring you back a little bit. So, so that's why I think of like animals. Animals, they don't think about future or past at all. Like they literally have the ability to stay in alpha waves all the time. Like they don't care what happened 3 seconds ago, and they don't have any idea what's going to happen in 3 more seconds. So all they're looking at is where they are. Oh, there's the sun and some nice trees. Where my mind's cluttered with, oh, I shouldn't have ate that crap for lunch, and what do I have to pay tomorrow, and all these other things, you know? So it's really just trying to be focused in the now is one way to activate alpha waves, all right? And what's awesome is the socks dip into that 8 hertz to 10 hertz is they start to activate alpha waves in different parts of the brain too, which is outstanding, right? When you get above about, 12, 13 hertz, you start getting into beta waves. These are the ones we use almost all the time we're awake. When you're alert, you're probably in beta wave most of the time in most of your brain. So this is what you use to do problems and, you know, judge things and figure things out and how to just navigate life, especially how to focus and things like that. Now, the interesting part, there's gamma waves. Now, gamma doesn't just stop at 100. It's not some magical number, but there has even been reports of things over 100 hertz. But the interesting part about gamma waves for me is our brain cells don't have the physical capacity to generate heightened gamma waves over 100 hertz, but yet we still measure in certain people they're over 100 hertz. And it's like, well, how does that exist? So then there's these theories that our brains are just these big antennas that are just getting information, and we're just reverberating it around. We're not actually creating our thoughts. So that's a whole nother philosophical thing we can get into. But gamma is really interesting too. But again, these are the ones where you have to be able to produce or process so much information coming in at once. And again, soldier on the field, it's like all this stuff's coming at you all the time. You have to be able to take the pertinent stuff in, make the right decision quickly, and so you have this heightened level of performance. And this is kind of what a lot of the athletes talk about to me, where they say they're in the zone. Like they're just like, yeah, I was just on, I was visualizing, and like I couldn't make a wrong step. But the other cool part about these brainwave levels is this is where when you have somebody who is fully present, but they give this altruism, like somebody who will sacrifice their life for you knowingly, right? They'll jump in front of that bullet. Or like Mother Teresa, she's just taking care of people selflessly, like no regard to who she is as a person. Her mission was always just to care for the thing in front of her, whatever it was. That was a heightened gamma wave state. So it was really interesting. Almost like they can feel superhuman is a lot of the reports when people are measuring in these gamma waves. They just feel indestructible. Kind of like a lot of the teenagers I treat here. They're just like, oh, I could walk through walls, no problem. There's no consequence. And it's like, calm down. Like their brain is just going, you know.
So people with ADHD, would they have heightened brain waves as well?
Yeah. A lot of times the ability to focus is a lower brainwave. So if their brain is less inhibited, right, then out comes all this hyperactivity. It's very possible. You know, ADHD 2 is also a lesion, usually in a very particular portion of the right hemisphere. Okay, so a lot of times it could be their whole brain is working, and there's a gift there, in my opinion, even though it may not be socially appropriate all the time. But if you can harness it just to get them to jump through the hoops, a lot of times people with ADHD, they produce things from nothing. They invent stuff, you know, that's useful. So yeah, it can be a hindrance, but there's also a gift there if you can harness it, you know.
Yeah.
So yeah, gamma waves also are talked about with perception and consciousness. This is the idea that the brains are antennas, that there's this universal consciousness that's measurable, but it's hard. How do we do it consciously? It's beyond our capability. That's the interesting part. So anyways, this is just the doctor that mapped it out back in like 1909. He saw the different neighborhoods in the brain that all had very distinctive things. So all these colorations are his numbered areas. And I think I have another slide here where it shows all these different regions of the brain. Now, again, keep remembering Dr. Thatcher's study where he showed the red starting to increase in activation. And if you would overlay that red, you'd see it's so many of these areas here. And on the flip side of the brain, on that inside middle portion of the brain, you got all these areas in the inside too. So these areas were all influenced. And you can look them up, like what is area 3? What is area 1? What does area 2 do? Like you could look this up. It's very, very well rooted in neuroscience and accepted knowledge. So that stuff's been around since 1909. I always think of Broadman areas of the brain as a neighborhood, right? Different floors, different buildings. This in particular is Amsterdam. It's just so diverse of an area where block to block, there's different types of neighborhoods, different people that live in different neighborhoods, and they all have different functions that create this whole community. And brain kind of has that same sort of thing. Everything gets along, but some parts are more important than others at particular times. So this is kind of the Broadman map on a real specimen here, you know, just overlaid with the different numbers and things like that. So we'll go through a couple of them, and then I'll show you some. So one other concept I want you to have an idea of when you're looking at brain activity is that all the motor that your brain is capable of moving your body literally has the exact same influence on your cognition, your mental awareness, as well as all your emotions. So in this picture, they're just showing, this is like a cross section of the brain down, like if you were to cut the front of me off and look this way, okay, you'll see these islands of cells that sit, they sandwich with each other, right? So the red ones are representing the motor circuits of the brain, okay? The green ones are representing the mental part of the brain, like the psychology, who you are, your IQ, your intellect, your judgment, your planning, things like that. Then if you cut down the middle of the brain, you get to that spinal cord midline area, the blue part, and then you see the blue and blue. See how much bigger the blue is? That's your limbic area. That's your emotional system, right? Your brain dedicates so much more to your, essentially your instincts than it does to your whole motor system, which is pretty profound, right? So the interesting part like this is like when I walk into the room to meet a patient for the first time or anybody, the emotional system of them and me already made a judgment call before I even perceive them as an image in my brain. Should I move to approach them or should I back out? You know, so if I met you know, Terry in my waiting room, you know, he's happy, he's nice, he's well groomed to a flaw sometimes, and you know, I would greet him, I'd shake his hand. But like when we were walking around Toronto and I turned a corner and he was just a you know, meandering, wandering silhouette of a man, I got a different sensation and I didn't even recognize him, so I had to turn around and run away. So sorry for leaving you that night, but
That's okay, pal.
yeah.
I found
Then, yeah. So again, this is that study. I'm just trying to reiterate, like those areas of the brain that showed the application of the socks and all the Broadman areas it lit up have very, very far-reaching clinical things. Now, it's not to say using the socks can treat all these different areas of the brain. It just shows, it gives us the ability to activate these cells so that the brain feels these cells are more pertinent. It keeps them around longer. And if you engage in activities that utilize those cells, whatever those functions may be, then you're going to just have a healthier brain, which then ultimately leads to healthier functions outward. Okay, so I won't go through all of them, but these were like the 10 to 12 different ones I picked out to go through each sort of one. So in that study, if you notice, like, let me see here, like the middle part of the brain right here, right? That's essentially this part right here and this part right here, right? Those are the middle part of this right in here, okay? Right here, it's just a different view. Like if you were to take a brain, cut it, and then turn it and look on the inside again, like then you'd see this medial wall part. This is where the foot and the leg is, right? So if you touch the foot and the leg, you'll see this area light up with activity, all right? If you touch the hand and the thumb, you'll see an outside portion of the brain light up with activity out here. And then if you touch somebody's face, you'll see the bigger portion out here light up with a lot more activity, okay? So that's what this is called, the homunculus. If you look it up, it just means little man in Latin, All right. And this is essentially the sensory in blue and motor in red is how much real estate your brain dedicates to different body parts. And if you look at this with detail, if you look at the area of the face and the thumb, those areas in the brain, it literally takes up more brain activity and real estate than my entire spine and torso. Right? If you see that relationship. So the interesting part is, like, I mean, if you think about it, this joint right here, just our thumb, right? I mean, this is what got us out of the jungle or out of the food chain, essentially. Like, we don't have to worry about cheetahs hunting us down. Most of us on Earth don't have to worry about that anymore, right? Waiting at the bus stop and then a bear comes out. I mean, I don't know, up in Canada, I'm sure you got to worry about a lot more of that than I do here. But this stuff is like so important to the brain. To the point is, there are some patients I treat where literally they're coming in for a variety of conditions, and some of their treatment plans literally involves like doing things specific with their thumb while doing stuff sensory wise with their face. And all of a sudden we'll get migraines to dissipate. We'll even get movements back in their face and all sorts of stuff. So it's really interesting, the functional relationship, that how the brain looks at your body. So this little guy here is somebody made it out of clay, like how important the brain looks at what your body's represented. So a lot of it is really your face, but more importantly, lips and tongue and hands and feet are probably the most represented in the brain. So it's really an interesting way to look at it. And then I go through all these different functions, but we're not going to go through all of them today because I could spend probably about an hour on each slide if we needed to. But I just want you to have the idea, these are some of the most important functions that I see walking in and out of my clinic that are lost on people who suffer immeasurably. And these are also the areas that the application of HTP literally help wake up. So then I can help give more fuel and activation to those areas of the cortex. At the same time, I do my specific stim in the way I'm trained, and then we just get this overall better net effect. All right. So this is just showing the movement areas. This one is like the judgment and planning areas. Like, your motor system is quite remarkable when it's used correctly. It pretty much can predict your future for the next moment or two, because it has to know that, well, the world's going to be here, and this is how I have to move from where I'm standing here. And when people don't have that area working right, again, this is this area highlighted here, right? And this is the area, I just put this here. This is kind of how Vox helps all these areas of the brain right here. So that would correlate with this strip right about here, okay, in the study. So folks with problems here, they have postural control issues. Like people who they gotta, get up real slow, not just because of pain, because there was a point before they actually perceived the pain, if it wasn't trauma induced, that things just weren't moving right. Like there was a delay, and then bones start to rub on each other, and all of a sudden you have arthritis, or you blow out a disc, or you sprain a ligament. Those sort of things. Before you actually get the injury like that, the scene was set well before that, and usually it's because of this area of the brain isn't coming the threshold. So, and then lesions, you leave stiff. This one, these are just eye movements. Like I said, a lot of what I do is heavily rooted in how your eyes and your equilibrium are tied together, because that's what sets the tone for the rest of your body, essentially. So it helps with that area. It helps with decision making. Like this dorsal lateral area, these are some of my most favorite areas of the brain, where these are the areas that help you make the right decision, have the appropriate emotional response based on what you're seeing. And Paul's mom sent me this, but for him, he was just trying to figure out which cookie to eat, even though he started eating a little bit of each one. He's like, I don't know which one to finish first. And like Paul, he had a problem with that dorsal orbital frontal area of his brain. So the socks have helped Paul so much. Yeah. And then this was a funny thing I saw, where that Who Wants to Be a Millionaire show, and what's the first letter in the English alphabet? And A is C and C is A. and there was just a whole bunch of confusion in this sample clip. Again, it's playing with the orbital frontal. And they just kept volleying back and forth, like, it's A. Well, A is C. Well, no, it's C. C's the first letter. And they just kept going back and forth, but it was pretty funny. And then this, there was another doctor who asked me to help him move. I said, you got a truck? He goes, no, we don't need a truck. I just got to move this couch. I'm like, all right. He goes, we can use my station wagon. I said, fine. So talk about his orbital frontal decision-making process. He thought that could fit in that car, right? Lesion, like that's a problem right there. Like just poorly planning actions. I mean, and that's a very real thing. We all have that. Some days it's better than others. You know, he was having a pretty bad day that day. So the other one, dorsolateral frontal. This one is like your executive functions. This is what helps you have like conscious controls over emotions. Now, that's not to say you have control over your emotions. Your emotions are generated based on your brain's perception of your environment at that moment, right? So if you're in traffic and somebody cuts you off, right, you're gonna feel this sensation, right? I haven't met anybody who's happy in traffic yet. So I'm gonna assume it's universal. Nobody really enjoys lots of traffic. So traffic creates this emotion in people, right? But what you do with that emotion is a responsibility of the dorsolateral cortex. That's the ability so that you don't get out of your car or hit somebody on the road or have road rage or things like that, okay? So when you lose control, that's when you start seeing poorly manifested motor responses to emotionality, right? So if you have a lesion there, one, you have bad eye movement, so you can't see the world appropriately. You have delusional thoughts. It can lead to schizophrenia. It can lead to depressions and anxiety. And then you get inappropriate social responses, like you have a monk flicking off a garbage truck. So those sort of things is just like, those shouldn't be, right? So something happened to give us that response. You can look up Phineas Gage. He's a really famous character in neuroscience literature about a gentleman who had part of his brain essentially blown out, but he survived. But what they noticed about him was his personality drastically different, right? Now you would assume, yeah, you got part of your head blown off and you're still living. I would think your personality is going to change anyway, but they're correlating it with the particular region of his brain that went missing. That's how neurology was really discovered, was they knew somebody who was just a complete tool, and they're like, Jesus, and then the guy dies, and then they dissect him, and they go, oh, look at this, he had a tumor growing in this area. Well, then if you have a tumor growing in this area, that's the area that must make you a saint. And he lost that, you know, that sort of thing. So this is a very famous story in literature. Cingulate one. This is the one that regulates all of like your heart rate and blood pressure. This is part of your emotional system. Heart rate and blood pressure. That's why like people with chronic stress have high blood pressure. Or if we take blood pressure here and somebody's been sitting in traffic for two hours and they're 10 minutes late or something like that, their heart rate, their blood pressure is through the roof. And it's all because their emotions are generating like, oh, we got to go, we got to get there, we got to get there, you know, that sort of thing. So if you have that every day, you train that part of your brain to keep your pressure up, okay? So those are the things I'm very passionate with trying to get to calm down, because a lot of times the slower the heart, the longer that body lasts, essentially. So decision-making, empathy. So Vox just showed that it touched on all of these areas and beyond. I mean, it did way more than just these certain 12 areas. This was a fun test I had the whole crowd go through. It's called the Stroop test. And really, what I want you to do is say the color of these words as fast as you can, right? Just the color, not what the word says. Say the color of the letters, right? So do this in your own head, like green, red, blue, right? Got it? So then what you do, now say the colors, right? A lot harder. Red, green, blue, blue, red, green, right? See, yellow. So that just shows ADD, that could be schizophrenic. There could be so many different things when the timing is drastically changed, right? So those are lesions in the emotional regions of the brain too. So little tidbits like that. But again, Vox helped increase the activation to all those regions of that portion of the brain. So The interesting part, the temporal pole right here, right on the tip, that's a lot of times we see in demise in people with concussion, and people start to get dementia. Early onset, late onset, doesn't matter. But they start to kind of forget things, and then they forget social attachments to things, and just they can't read facial clues for emotion, right? So people who can't tell you're pissed off at them, and they just can't relate to you, or people who can't get sarcasm. That's usually one of the first tests I do just in the conversation I have with patients is I lay on a lot of sarcasm to see can they decipher that my tone doesn't really match my face to match my words. And if they can, chances are they're not really headed toward dementia. It's almost like a screening test.
Now, Dr. Joe, I know we don't have studies for it, but are lesions healable with neuroplasticity training and/or are we seeing? Do you feel that wearing our neurological product that lesions could be reduced or healed?
Yeah. So I know we don't have the studies, but the potential from the studies that we do have and what I've seen clinically, being exposed to the socks or the patch and definitely has the ability to increase the firing activation of brain cells in especially these areas that we finally captured. So yeah, and if they have that ability inherently, that means they're making neuronal plastic changes, right? So then wearing them and doing your same routine versus don't wear them and do your same routine will have a drastically different brain effect overall, but it's over time, just like anything. You have to practice to make perfect kind of thing, So yeah, being exposed to the tech, yeah, ever since, I got involved and I'll show you this one study with this hockey player. It changed everything about how I practice, but also even how I use the socks for me personally and with my family too. Because before it was like, oh, we'll use them when we work out. We'll use them when you're feeling, I got a sore knee or something. But then when I saw this, then I started really noticing when I didn't wear them for days in a row, I started noticing little things creeping back into me. Just that's a little more sore than I'm used to, or not recovering as faster as I did, things like that. So really the idea that I use it for is that in order to have really good brain function, you need the brain to be balanced, on itself, not just left side equals right side, because it's never going to be symmetrical ever. It's just going to be depending on what the brain needs to operate to survive in the moment. That's when the brain has to go, okay, we have to be able to sit still, have to be able to concentrate and talk, right? I don't have to be running on a treadmill right now, right? So it has to do the appropriate things for the situation. So the brain has to be flexible, right? Because if all of a sudden my door opens and in walks a bear, well, I have to be able to change that, right? Yeah. So you got to be resilient too. You have to be able to bounce back from things. So a lot of things cause imbalances, you could imagine. These are just a few, right? So life is going to cause imbalances is what kind of the conclusion to all that stuff is. It's just going through life. I haven't met anybody who is like, no, I'm good. Like I haven't met, at least, I haven't met anybody that didn't have any of these sort of things. So in my opinion, if you're going to use something that's just going to help fight against the normal stuff you deal with the moment your head leaves your pillow, essentially, then it's just like, well, why not do something that's going to just help you in the background? And use the ideas of neuroscience and neuroplasticity, the stuff that we already know exists. Well, why not do something that enhances that quality that we already have, And one thing that I was taught growing up was, my grandfather always used to say, like, just remember, all you have, the moment you open your eyes in the morning, you have all you need, is kind of how he would put it. It's like, you don't need anything else. He's like, you have it all. You just have to figure out how to use it appropriately. Mm-hmm. And this is just something that's just profoundly adheres to that sort of guideline. And HPT keeps brain cells pertinent. I truly, truly believe, based on those studies that we saw, it gives brain cells that may be not used on an actively daily basis, but it gives them some kind of activity so that, they're going to be reminded to stay around a little bit longer. So this is kind of balancing. You need to be flexible, be resilient, right? But the study literally shows that HPT enables you to increase the potential for all the brain activity, in my opinion, because it's literally showing increased brainstem activation, which then spills over into how the brain tissue itself balances itself, is what it appears like to me. It just looks like, because if you notice in the study, the left hemisphere got more activity than the right hemisphere in most of those 60 participants. So what does that mean? If the socks were put on both feet, then both brains should have gotten the same amount of activity. But to me, I look at it where that just means the brain took in as much of the information that it needed, and it needed more going to the left side than it needed going to the right side. So it's like the brain knows what it's doing beyond our minds know what we're doing. You know what I mean? Yeah. We don't know how to move. I couldn't tell you how I get up to get to the door, you know, but my mind just goes get to the door. My brain is the thing that has to carry out all the complicated procedures to ensure I make it to the door, you know?
Anatomic, I mean, it's like Jay has said before, we don't have to think about gravity.
Yeah, yeah, but we know it's there. Yeah. So
you can drop a piece of paper from the top of your desk. You know, you can hold that piece of paper up and you let go of it, it falls to the floor because it doesn't have a brain.
Right.
So,
yeah.
It's a very clear example. It shows the anatomic function and how important it is to, you know, motor control and doing those things that we just do naturally or hope to do naturally.
Yeah. Yeah, exactly. There's so many things like that. So, yeah, perfect. I'm just saying, this is just a summary of kind of what that white paper shows is that the tech has the ability to reach so many different areas of the brain. I think it was 44 different regions of the brain out of the 52, out of the 52 Broadman areas, 44 of them had some influence based on exposure to the socks. Wow. I mean, that's pretty profound. It's like saying it activates the brain, but it's so difficult because it's trying to figure, you can't label that with conditions now. You know, we're so used to being, hey, well, what do you call what I have? And, you know, in my office, I don't deliberately diagnose somebody because sometimes people get stuck on the diagnosis.
Well, yeah, you know? And I think that became very clear because we elicit the response in the brain and we don't always know what the response is going to be. I mean, the lady with the vocal cord damage, did you see that one, Joe?
Oh, yeah.
Like, I mean, Jay didn't design this to say, hey, I'm going to help people with bad vocal cords.
Right.
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 So the brain self-regulated. Said, okay, this is what we need to, you know, this is where it goes right away.
Right. Yeah, exactly. So it's just like, yeah, I can't say enough good things about the brain, but that's my brain saying that essentially. So.
But there's, like you made it very clear, the brain is different than the mind, right? So.
Absolutely. Yeah. And it's, in my opinion, as far as, like, because I see a lot of suffering in a lot of people, you know, that's kind of what I'm used to seeing, at least in the initial phases when I meet somebody. And it always is rooted in the mind first. And I don't talk to the mind. I just look at reflexes, how somebody moves, how they balance, and then what can I do to influence the brain's response. And what's interesting is you start to see the brain respond better, and then the mind changes as a consequence. You know, so
I know that whole thing. I mean, you know, that when I first saw that study of the hockey player, I got pretty emotional about it.
Yeah.
Just because, you know, I played the sport, I had concussion damage, didn't realize I had concussion damage. I mean, we basically had a smelling salt broken under your nose, and you know, one shift later, you were cross-eyed and sent back out in the ice. You know what I mean?
Oh, yeah.
To see that, you know, to see the technology wake up the functionality, and you know, it's going to take time, but to see that it went from, you know, and I urge you to bring up those slides to show how fast to listen. This was even at a point, hey, Dr. Joe, when you just sort of threw it out there and said, hey, I got these socks. You just learned about them and said, maybe I'll give these a try. And
yeah,
see where it went. And for me, I know that the clarity of mind that I have seen by wearing this technology, and being able to stay on point and my task orientation and getting stuff done, in a list and that sort of stuff, is improved dramatically.
Yeah.
For me, wearing this tech since late 2015.
Yeah, no, man. I do it all the time, but that I'll share that case next. That definitely is real important. Let me see. So let's see there, and then kind of wrap it up. Just to show you the study again. But I'll go through this case, and like I said, this was a hockey player, 17-year-old kid. He from what I remember, he got hit into the boards, hit his head against the boards, or he took an elbow to the boards, hit the boards, and then he was unconscious, and then fell and hit his head on the ice where it kind of bounced. And he was sat there in a daze for a bit. They pulled him off the ice. He just sat out the rest of the game. But, he wasn't himself. He really wasn't in any pain. He was just like, oh, he just kind of felt dopey. And he had a headache. But then he got in the car with his family. And a few minutes into the drive, where they're just going home, his mother said, the first thing he said was, you all look like really nice people, but can you bring me back to my family? It was just like, so, immediately they drive to the ER because they're just like, well, what the hell? Like, he didn't recognize anybody in the car. That was his brother, his sister, his parents. And it turns out the way he got hit, it broke some blood vessels up in the brain, and he started to have a bleed. And so they did the surgery where they decompressed the bleed, they stopped the bleeding, they healed him up, and they sent him home. It took time, but they sent him home. He didn't really have any physical demise, nothing. He didn't lose limbs, he didn't lose anything. But what he did lose in a very particular region of the brain, if you could imagine, the area of the brain you actually feel that good feeling of like love and hope and respect and honor. That's literally a physical area in the brain, and it's only elicited in a very particular set of circumstances. So, your mom growing up, your dad growing up, like those you should recognize the people that elicit that feeling in you of like love. But what happens is if it gets damaged, you recognize mom as mom or dad as dad, but you don't feel the emotion you should feel toward them. So to that brain, they'll look like imposters. Like, yeah, I know that looks like mom, but I don't feel that way about that person, so that's not really mom. Those something that it's a real phenomenon. They call it cop cross syndrome, and it's horrible, especially for the family, because then they're trying to convince this person, no, you do love us, like, remember, but if it's damaged, it just doesn't work like that anymore. So this kid had those signs where just from this concussion, it just shut that off. And so they decompressed him. Before the injury, yeah, he was like star pupil. He was involved in every sport all year round, like from hockey to soccer and rugby, and he was always involved in team building stuff. He was also, I want to say a junior, he was like on debate club, and he was in line to go to a law school. Like, he knew he wanted to be an attorney or a judge or something like that. So it's like he was 17 years old, and he had like everything put together. I mean, it was pretty impressive to hear about his history. And then when I meet him, he's literally staring out my window, and it's snowing, like one of the first snowfalls, and he's just staring at the flakes coming down like it's the first time he's ever seen snowflakes. Like he's looking at him like pure, like it was beautiful in a way. He was discovering them for the first time, but at the same time, it was like, how could he not recognize that that's snow? He's been around Chicago for his whole life. He knows what snow is, but he just couldn't put it together. He's just like, he was so infatuated with snowflake. So here, it was so sad to see. And when I met him, yeah, they said they went to 22 different areas around the country before, just word of mouth, he found his way to me. And then I just started doing exams. Now, when I do an exam, I look heavily at how eyes move, okay? So the ability to see movement in somebody's eyes, or your conscious ability to move your eyes, takes up so many different regions of the brain. So I just put this slide up just to show you how intricate, like if I just tell the patient, hey, look at my thumb and follow it about 20 to 30 degrees from side to side, right? That's all I'm asking to do. And this is how many areas of the brain have to come online before you even see the eye move, all right? So first, the image hits the retina, right? Then it hits this part of the brain, that goes to this part of the brain. And I just drew this all out. We're not gonna go through every area, but if you just get the idea, look at all these things that have to keep firing in a very particular sequence in order for you to get down to the actual movement of the eye. You know what I mean? So that there's over 21 specific things, but there's probably over double the amount of actual activity that has to happen in order to just see the eye move. So when I'm watching somebody's eyes move, you can kind of pick apart what part of the neuraxis is failing at these areas. So then you actually know, okay, what kind of eye exercises can we give them to get the eye moving better again, or something else, you know? So there's a test I use called saccadimetry, where it measures the speed and accuracy of how fast an eye can move from target to target, okay? So if I have you like see my thumbs, and you look at one thumb, and then you look at the other thumb, and just notice if you keep going back and forth, right, you don't see anything in between, right? Your eyes move so fast that you're blind, right? And so if eye movements go so fast, you don't see anything. Now, what happens in concussion, or a lot of different conditions, is your eyes will constantly slip. They'll just and you won't even notice them because, again, they happen so fast, you don't perceive that you just looked away at something different, right? It's almost like if you're driving and you look at your speedometer real quick. I mean, I hope nobody here drives and looks down and then looks up. Like, that's a long time to figure out how fast you go. Most of the time, it should be like this. You're looking down, up. And then what you just saw literally plays in your head a second or two later to give you the idea how fast you were going, right? So those are appropriate saccades. You shouldn't have to stop and delay to see every little thing, right? So we have this device you wear on your forehead. It shoots these little red laser pointers out at the wall, and it measures, these little lenses measure how fast and how accurate your eye moves, right? Now they have to move a certain speed because this is measuring in milliseconds. So if your eyes move too slow, the saccadometer doesn't pick up that your eyes even moved, right? So if it's not quick, then your eyes move like this, it'll register as no movement, all right? So this is what happens. It shoots these little dots on the wall, and each one appears at different intervals. So you look from side to side to side. That's all you're doing. It's like 50 jumps in each direction. And it gives us a report. So it gives us a report of red means the eyes are going to the right. I'm sorry. Red is the eyes are going to the left. Green, the eyes are going to the right. Okay? So it tells us what part of the brain is pushing the eyes in each direction. But at the same time, what you want to see is the green and the red, left versus right, be intertwined. You want to see them as close to symmetrical as possible, right? And you want to see these nice groupings where there's an up, there's a down. There's like a ponytail, and then you get these little rises with these caps on it, right? So you just want to see these closely grouped and even. Now, when we did this hockey players, when his initial visit came back, this was his first test, right? So that's vastly different than what I want to see. Now, the one on the left, that's kind of normal. That's where we want to see everybody, especially at the end of treatment and stuff. But
So
the one in the...
Let me ask you a question. You tested him, and how long after the injury? Because he would have had his operation. How long, 22 visits, had it been since he was concussed?
Geez, that was probably... It had to be over a year and a half.
Year and a half, wow.
Since his injury, and he's gone to 20-something other places for treatment, not just assessments. You know, like he went to Mayo Clinic, and they did a ton of assessments, but no treatment. You know, like, so he's been through the ringer of testing and then trying physical therapy, occupational therapy, sports therapy. They were trying everything, but he had nothing really structurally wrong with him. It was all just a miscommunication of things happening up in different circuits of the brain. So this initial visit, when he showed me that, it, to me, like, you know, like, I get excited with most people I meet because there's always something I could pick up, like, oh, we got some hope, like we can do something with this person, you know. It doesn't mean cure, it just means I think we can help somehow. So that kind of gives us a lot of momentum. But when somebody comes in and he should have showed me 50 lines in each direction, so 100 lines, and he shows me one, and it's inaccurate. Like, that is not even close to any of these other graphs, you know. So when I saw that, I was kind of heartbroken for him, going, like, I'm just number 23 on your list now. Like, I don't think I can help you at all. And rarely have I've only turned away about maybe 8 cases in my whole career where I was like, you know what, I just don't have enough knowledge to help, you know, or I don't have the capability to do this. Usually we could do something, you know, because as long as brain's alive and we could find a way in there, you could even help people in a coma. You know, it's remarkable. So that's when I just got introduced to Vox, not too far before this kid hit my clinic, and I was still playing with the idea with Vox just on a personal level. Like, I was using it to train and rock climb and run and stuff like that. But I had these extra socks here, and I told the kid, I said, hey, listen, put these on. I'm gonna reset the test, and I just want to see if anything changes with your eye movements. Now the way I was taught to help eye movements is I have to give you specific targets, head movements, and retrain the calibration of how your eyes are situated in your skull, essentially, and have them match your equilibrium and neck movement. And you know that it's always taken repetition and practice and very precise observations in how to move somebody's head so their eyes move corrects them in their skull. And so I put the socks on him, and he's just sitting there, and he's kind of making little jokes here and there. And I'm resetting the test to put back on him. And I wrote 5 minutes here, but you know, I think it was closer to 10 minutes. You know, it was in the middle there somewhere. But so say about 10 minutes later, I have him set up for the test, and I rerun the test again. Again, same test, 50 dots in each direction. And this was
now with the tech on.
This is with the socks. He's been sitting there while I've been setting this stuff up. And like I said, I think it was more like 10 minutes. Okay. You know, if I can remember it, but it's hard to remember all of it. But this was his test after. Now, by no means is it accurate, but to me it was like, oh, like now I have something I can work with. Like, you just gave me brain activity that I can use again. Like, all of a sudden it just turned his eyes back on, or turned those areas that controls the eyes back on. Whereas a minute or 10 minutes prior, I had nothing. Like, I literally didn't even have a substrate to work in, because it's like, if I give him eye movements, I'll fry him even more. He just didn't have the activation, so the health of the system was so poor. So then after we did this, I was just like, I was blown away.
That's where I looked at that, and that's where because I can't even imagine, you know, what he would have felt, you know, inside, because it's like that creature caught inside that can't get out. Like, I think it's somebody with Alzheimer's or something that, you know, just can't get out. And I'm thinking, to see, you know, something light up in his brain, and I'm wondering if he physically felt it, you know, as quick as it showed up on the graph, if he felt
right.
something.
Yeah, and I remember talking to him, and he didn't seem any different. You know what I mean? Like, he couldn't, his perception of stuff was so squashed anyway, you know. But so I showed his parents right away, like, and we, you know, we canceled a couple of patients and moved them around enough, because all I want to do is focus on this kid that night. And so I begged them to stay. I'm like, keep the socks on. do some exercises, do these particular things with me, but use the socks. And I want to see what happens. Give me at least an hour, right? So they were just like, yeah, we'll do whatever. So, you know, we closed down the clinic, and then it was just us trying to see what we could improve with this kid. And we kept testing him. And after about an hour of him doing stuff, I mean, he was tanked. Like, literally, he was like, yeah, I'm tired. Like, I can't keep my eyes open anymore. But we were like, one more test, you know? So the idea was try to get this cleaned up. So now we're combining, one, the Vox stuff helped me get his brain back online, but then now I could use the stuff I'm trained to do to kind of fine tune it, you know? And that was the idea. And luckily, it all worked wonderfully for this kid and this family. So that's him. That was him after about an hour of us doing movements with his head, having him follow targets. We even did some music and chiropractic stuff. We spun him in a chair as well. I mean, we did so many things that night in a very short time, but it all kept showing that it was cleaning up this kid's graph. So, I mean, this was incredible to see. Like, this is where he came from, and that's where I eventually want to get him to, you know? So it was one of those profound cases.
You must have been at that point just going, OMG, you know?
Oh, yeah, not in those letters, but yeah.
But I remember when you first showed me this, and I mean, there's comments on the screen now, Dr. Joe, that you can't see that, you know, people are just saying, I'm in tears. This is huge, so brilliant, love the story, amazing.
Oh, nice.
And I know, Joe, you're a rock star. I'm not sure whether I agree with that one, but that is so remarkable what these socks can do. Well, it's what this technology can do.
Yeah.
Jay must be so thrilled with this story, life-changing for this kid.
Yeah.
Ronnie says, my mind is absolutely blown. And I know what people are saying, because I remember, you know, when you first showed me this, and I can relate to that because I've seen so many players, you know, get concussions. And Sean Rice, who's on this call, who's, you know, was an Olympian or world champion, you know, and he had a head trauma from wiping out, you know, doing, you know, not trying to land on somebody and went off balance, and so he knows what concussion is. So to know that, you know, with this technology, that there's hope for some of these cases where there was no hope, where you look at this, and even you, new to this technology, and thinking it's just kind of sitting over here, and well, it's kind of like, well, I don't know enough about blockchain, but what the hell? Let's throw it on this kid and see what happens. And then you do the test again, and you have this kind of stuff showing up. I know it's probably a TSN turning point for you to say, hey, I want to know more about what's going on with this technology and how I can, you know, facilitate it in my practice to help people. You know, I think it's.
Yeah. Oh man. I mean, and this was a whole nother level of, like, some of the best compliments I've ever gotten from patients is not that I could help them. You know, it's hard to help everybody. It really is. But the fact that we're able to give people even another glimmer of hope, and not false hope. It's not like I'm blowing smoke up people's asses. Just it's like I really think we can do something here. And now, and I have technology that can show these measurable differences, you know. And we even have a plaque from a lady who made us, like, she made us this thing out of wood that just says, like, HOPE, and it's like, hold on, pain ends. And it sits in the waiting room, because it's just like, just give us time, maybe we'll figure something out. And when I got introduced to Vox, and I wish I knew about this stuff, you know, 15 years ago, but you know, it exists now to be used now, you know. And yeah, I just love that.
Today.
What?
How is this kid today?
So when was this? The kid today. So he dropped out of high school at that time, right? And he focused on just rehabilitating his brain. Now, this kid already had a great brain to begin with. You know, he was an athlete. He was, you know, going to college. So it's not like he was a dud anyway. He just got dinged, and that caused a lot of inflammation. So once we fixed that, and then he started getting the more accurate firing patterns in those different circuits of the brain. He finished his he got a GED, which is like a high school graduate equivalent. He went to a year of community college, started on a traveling hockey team, and then he wound up getting an academic and hockey scholarship to a Division II college. And I think he's just about to graduate right now. So graduate with a bachelor's degree.
So he came from there wasn't, and the picture on the right, there's not a chance he could have accomplished that.
In my opinion, no. And that's not being insulting to him. It's just he wouldn't have had the facility to even be able to read and comprehend something.
Yeah.
You know, that was the kid he just infatuated with snowflakes.
Yeah,
yeah. You know,
like a 3-year-old amazed with the snowflakes coming down for the first time somebody wrote.
Yeah.
But no, I mean I mean, you as a as a practitioner, when you saw this, I mean, I can imagine. I know what I felt when I first saw this, knowing what that kid, not only what the kid was going through, but what his family was going through, because it was like almost a personality change. Right?
It was, and the mom was not shy about how she felt at all. So I mean, there were like a lot of emotions when they came in the office. It was, we'd have to have them at the end of the day or the beginning of the day, like, because they would influence the whole waiting room of people, you know, because the mom would just be, you know, like crying some days and, you know, super happy other days. You know, it's one of those cases. It's just you're invested in it wholeheartedly. It's not just like, oh, I clock out at 5 and I forget about them. You know, it's just.
Yeah, I think it has to be that people also have to understand that there's a healing element and a timeline to everything, and Vox certainly encourages that and helps elicit that healing faster. We know that and have proven that, and certainly this would have helped in this guy's recovery. You know, quite as we see that, you know, that brain lighting back up again. But exciting to see that from, you know, the technology's ability to elicit a response in the brain and putting it on. I mean, it's no question. I mean, you go from those images on the right to the center, and knowing that, hey, we can work back towards the image on the left on the screen here.
Yeah.
And work towards getting him back online or close to as normal as he could have been with this injury is exciting to know. And you know, I think that speaks loud and clear for the importance of wearing the technology, because we are electric. When it's on, it works. It doesn't work in the drawer, right? So it doesn't work just on Thursday. If that's when you know, you don't wear it just Thursday. You wear it every day of the week.
You wear it every day. Like ever since that, you know, I've worn them. I started wearing them to sleep too. And it's like, when I was growing up, you don't sleep with socks on. That's all I was taught. Yeah. But then it's like, nope, this has helped me. And, you know, the first time I noticed it, and I didn't notice it, my girlfriend who I was sleeping next to, she noticed it. And she's just like, you slept all night. I'm like, no. And normally I don't sleep all night. Like my whole life, it's been, I'm asleep by 1, 2 in the morning. I'm up at 6. That's kind of, it was just a clock. And yeah, some days I felt more tired than others, but I tried everything. Nothing really worked. So I just said, well, that's just my brain and that's that. But then I started using them at night, and I'll start to get tired, you know, around midnight, and I can sleep through, you know, 6, 7 o'clock now. You know, it's been amazing. And I feel rested. It's not like you wake up and it takes a half hour to get going.
Well, there's probably a deeper sleep there too. There's probably a REM situation that may not have, you know, been going on for a lot of us.
Oh yeah.
The same way. I mean, I know that my sleep is a lot better when I, when I wear the technology compared to what it used to be. I just know by how I feel in the morning. You know, there's people who sleep and they get up in the morning and they still say, you know, I feel like shit, right? And then usually just because they haven't slept soundly or hit that REM stage for a couple hours, right?
Yeah, true. Yeah.
Yeah, so amazing. Well, we had a few questions. Let me just see. I want to make sure I'm all getting covered. In March, my 9-year-old got a concussion trying to jump from one pine tree to another. He was not successful and was very concussed. He would complain about concussion headaches, and within 2 minutes, his headache would be gone. This neurotech is incredible. Yeah, oops, he would put the socks on, and within 2 minutes, his headache would be gone. He loves his socks. Wow, it's incredible. That's Connie. That's absolutely. Thank you, Connie, for sharing
Yeah.
that. But anyways, yeah. Well, that's Joe. Despite the technical difficulties, I don't know. I still, to this point, don't know what happened. I had no idea. I logged out, logged back in. It was echoing. There's still 2 Terrys on the screen right now. There's still 2 participants that are both Terry St. Amans on the screen right now. So
Really?
going on, but hey, we worked through it. Everything's figure outable, and I think that my daughter's a beach volleyball player, and she won't play without tech on. You know, is it possible to form a tolerance to the tech? For example, wearing 24/7, 7 days a week, would the tech have an impact where the brain now remembers, or could we require some type of higher dosage?
Right. Now, so the remembering part, like that's the neuroplasticity part. We don't know exactly if there's a dose specific, but really what the pattern does is it fires the sensory system at a different frequency, so they all start to line up and stimulate the brain. The brain tissue itself kind of takes that activity and uses what it needs at that moment.
Right.
So in my opinion, you're constantly giving the brain novel stim using the tech all the time.
Right.
You know?
Yeah, that makes absolute sense. So there's always a positive effect, in other words.
Yeah.
Always. Yeah. Continual. Well, you getting so many compliments on, I don't know whether I want to read any here to you or not.
Say what?
You're getting a lot of compliments here. I don't know whether I want to read any to you or not.
No, you don't have, thank you all very much. I don't know what you're saying, and I don't trust what Terry's going to tell me.
They love you, brother.
Oh, I love them back, and I love the love. I really enjoy trying to help teach about this too.
Hey, man, it was so exciting to get you to jump on. I know I didn't give you a lot of notice. You got a busy schedule, and I love to throw you a curveball, but I know you can take it.
Yeah.
But seriously, brother, thank you so much for all you do for the field.
Oh,
all you do for teaching us. You know, your knowledge is just incredible, and I think it's really important that the field have an understanding of how the brain works and why this elicits a response, and to, you know, have some clarification with, you know, Dr. Thatcher's incredible white paper is, you know, great for all of us.
Right.
You know, I'm sure including for you and Jay and even Dr. Mark DeBrinket and so on, Medical Advisory Board. It's great to see such a great man like Dr. Thatcher jump on board and you know, make this very quantitative for us, so to speak.
Yeah.
Edify it and basically, you know, validate what Jay has been saying, even though it may be something that's really hard for the average person to understand. And I know Jay's working on, you know, putting it into layman's terms and getting us talking all the right language and so on. But
right.
Certainly, I certainly know that the field appreciates you. I'm seeing Grand Slam, Dr. Joe. Thank you so much. You're amazing. Blah, blah, blah. So anyways, I can't wait to see you again, brother, and hook up again. Hope Babby's well and everybody, all the kids are good. And
oh yeah,
we certainly all appreciate what you do here. So what I'm going to do is I am going to just unmute everybody, and then everybody can say goodnight. And hang on, I'm going to claim the host back. And now I'm going to unmute everybody. All unmuted.
I'm watching them and I'm like,
thanks very much.
thanks everybody.
Thank you.
Terry.
Thank you.
Thanks, guys.
Thank you so much.
Good night, Jen.
Thank you.
Okay.
Thanks, Dr. Joe and Terry.
really that.
Thank you, Terry.
Thank you, Dr. Joe and Terry.
Play with the idea with Vox just on a personal level. Like I was using